The James Webb Space Telescope is exploring objects in a very early phase of the universe, where the most precise measurements reveal the existence of large, fully developed galaxies. The search leads us to question the hidden mysteries of the universe. The telescope has reached the edge of the known universe, allowing astronomers to go back in time and uncover an unexpected finding. About 6 million galaxies existed between 500 and 700 million years after the Big Bang, when the universe was still in its early stages. The discovery challenged previous conceptions of galaxy formation. It was expected that smaller, newly formed galaxies would be found in the early cosmos, but these measurements show mature galaxies similar to our own, challenging previous theories about the early evolution of the universe. The James Webb Space Telescope uses infrared light to observe the universe, as this wavelength is invisible to the human eye and captures the faint light emitted by ancient stars and galaxies, allowing us to literally look back in time to about 13.5 billion years ago. This amazing capability of the telescope paints a shocking picture: mature galaxies at a time when the universe was thought to harbor mostly smaller galaxies. This finding challenges established theories of early galaxy formation, challenging 99% of existing models that describe these galaxies as clouds of stars and dust that evolved over time. When scientists examined the telescope data, they were perplexed to find such large, mature galaxies in the early cosmos. They were even surprised to the point of believing that they had initially misinterpreted the data, as this huge structure appears surprisingly quickly in the images. The research team used spectroscopy to analyze the light emitted by these galaxies, identify the elements, and calculate their actual distances. This method provides a more complete picture of these giant structures and their location in space, providing crucial information about their nature and origin. Despite these exciting discoveries, scientists remain open to different interpretations. Although the evidence points to these being mature galaxies, there is a possibility that some of these objects are masked supermassive black holes, further challenging our understanding of the early universe. By analyzing the telescope data, confirmed galaxies were identified as the oldest and most distant galaxies detected so far, dating back to less than 400 million years after the Big Bang, when the universe was very young. These discoveries have been verified through extensive spectroscopic observations, allowing astronomers not only to study the physical characteristics of these galaxies, but also to accurately determine their distances and assess their evolution. The recent findings focus on 4 galaxies with a redshift greater than 10, confirmed by spectroscopy. A redshift of 13.2 indicates an approximate time of 13.5 billion years. The near-infrared camera and spectrograph were used by collaborating scientists to make these discoveries. The James Webb Space Telescope Advanced Deep Extragalactic Survey Program is an ambitious effort supported by more than 80 astronomers and scientists from 10 different countries to study the most distant galaxies. The JADES program spent more than 10 days observing a small area of the sky near the Hubble Ultra Deep Field, explored by astronomers for more than 20 years with virtually every major telescope. Nearly 100,000 distant galaxies were discovered, each billions of light years away. The JADES team studied these galaxies in 9 infrared wavelength bands over a 3-day period, gathering information about the gas and stars in them. By analyzing this light, they were able to reveal features and obtain accurate redshift measurements. This allowed them to determine the intrinsic luminosity of the galaxies and how many stars they contain, helping to understand how they were built up over time. The discovery of these very old and distant galaxies gives us the opportunity to better understand the early stages of galaxy formation and how those initial processes have influenced cosmic evolution. The James Webb Telescope has provided revealing data on galaxies, planets, and stars, opening a unique window into the universe. The James Webb is expected to continue operating for at least 20 years and has already made very significant strides in scientific research. It has discovered not only exoplanets and newly formed stars, but also the oldest known black hole, revealing detailed information about its formation and evolution in the early universe. The telescope uses infrared instruments to view the cosmic past and has detected massive black holes that grew rapidly into the young universe. However, how they appeared so early in the history of the cosmos is not yet fully understood, posing a mystery for astronomers. These cosmic objects emit faint radiation that has been reaching across the universe since its inception, generating a growing interest in astronomical research. The search for how black holes arose so rapidly in the early cosmos remains an enigma, although a primordial black hole, presumably formed just after or even before the Big Bang, is investigated. So far, it remains elusive. Two main explanations are proposed for the abundance of black holes today. One explanation is that they could be remnants of giant stars that form faster than present-day stars. The other theory suggests that they may have arisen from dense clouds of gas that suddenly collapsed, forming these singularities in space-time. It speculates on the existence of a population of stars composed mainly of hydrogen and helium that formed shortly after the Big Bang and exploded, leaving behind black holes. Scientists are collaborating with the group that developed the MIRI instruments to detect an even clearer signal from the light coming from these distant galaxies. These emissions may provide information about the formation of the mysterious black holes in these galaxies and their cores. A set of 7 interacting galaxies has been observed, forming a protocluster, the most distant cluster of galaxies discovered so far. Simulations suggest that this system could become one of the largest and oldest clusters in the universe, with a mass nearly 100 times that of the Milky Way. The Young Space Telescope has revealed these findings, but it is not sensitive enough to measure the precise distances between these galaxies. It is like seeing cities from an airplane without being able to pinpoint the distances between them. However, it is expected that in the next 10 years, as technology advances, these discoveries will become more and more accurate. NASA's Observatory Telescope Institute plans to launch an instrument in the early 2027 that will facilitate the identification of galaxy clusters in the early universe, such as those found in this study. This new tool is expected to have up to 100 times the mapping capability of the James Webb. In the fields of exoplanets, James Webb has been crucial. It has contributed to the discovery and study of numerous planets beyond our own solar system. One of these is a planet whose name is HIP 65426b, a massive gas giant orbiting at a considerable distance from its host star, being 100 times farther than Pluto from our Sun. In addition, the telescope has captured amazing images, such as that of the M74 galaxy, showing structures and interesting space and details of stars and clusters. It has allowed the observation of distant objects and has revealed fascinating discoveries that were previously difficult to perceive. Although the universe is vast and can extend infinitely, there are boundaries and inaccessible places that we cannot reach, even if we travel at the speed of light. This is why the detection of a traveling signal from the edges of the universe by the James Webb Telescope is of great importance. Recently, after the first images from the telescope were released, researchers have presented stunning images of spiral galaxies. Today, we will talk about the incredible discovery by the James Webb Telescope at the edge of the universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, be sure to like this video, share it so it reaches more people, and activate the notification bell. New images captured by the James Webb Telescope are helping to understand some of the most fascinating questions we have about our universe. These images include giant planets, stars in the late stages of life, violently colliding galaxies, and ultra-diffuse galaxies. One of the most remarkable images captured by the telescope is of a massive swirling spiral galaxy that is enveloped in purple-colored cosmic dust. These stunning images are opening up new discussions and debates about what is going on in the vast and infinite universe. According to the U.S. space agency, ANGC 628 is the name of a distant galaxy recently captured by the James Webb Space Telescope. Gabriel, an astronomer at the Cosmic Dawn Center at the Niels Bohr Institute at the University of Copenhagen, has shared the image on Twitter and commented that this galaxy seen as a dusty skeleton, resembles our own Milky Way. Individual star nodes and supernovae can be seen shooting out, which can be studied in detail. NASA has confirmed that the spiral arms of NGC 628 have been photographed previously, but Hubble Space Telescope images in visible light do not show the same purple spiral structure seen in the mid-infrared image captured by the James Webb Space Telescope. Dr. Brammer explained that the same galaxies seen through the Hubble Space Telescope or ground-based telescope do not show the same impressive view that can be seen through the James Webb Telescope. Through the latter, one can see blue stars, red stars, spiral arms, and dust lanes. He explained that the dust streaks, which are reddish-brown filaments in the spiral arms, tend to obstruct the view of stars in the visible images captured by the Webb. However, in this case, we can see the light-emitting dust directly. Instead of seeing stars, you can see an image of the gas and dust in the galaxy NG 628, photographed by Webb earlier this year and stored in the MATS Public Space Image Library, which anyone can access. The James Webb Space Telescope has not been idle since NASA released the first 5 color images. It has been constantly capturing new images and uploading them to the MAX archive for astronomers to access. According to Dr. Brown, the telescope has captured something truly spectacular, a galactic whirlwind at the edge of the universe that is incredibly beautiful, but also haunting. In addition to this stunning image, the telescope has provided compelling evidence that the universe is full of amazing phenomena and objects. For example, it has discovered that a star in the galactic swirl is surrounded by concentric rings of light that emit radiation outward. Although Webb's diffraction peaks are not real, the rings are, and there is a disturbing explanation for how they formed. The star that has been observed with the James Webb MIRI telescope is actually a binary pair of rare stars in the constellation Sagittarius. These 2 stars experience periodic eruptions of dust that accumulate in layers and glow in the infrared, which has allowed the MIRI to observe them in detail. They are a binary system called coalition wind, consisting of a hot, massive O-type star and a massive wolf star. NASA scientists are concerned about the discovery of this unusual object and the obvious connection between these Wolf-Rayet stars, which are massive stars in the advanced stages of their lives and losing mass at an accelerating rate due to their nuclear fusion of heavier elements such as helium or carbon. They are very hot, very bright, and old due to their massiveness, which means that their lifetime is short. The 2 stars in the Webb 140 system have powerful stellar winds blowing at a speed of about 3,000 kilometers per second, causing them to lose mass rapidly. The elliptical shape of the object's orbit adds to the fear, as it indicates that the star describes ovals rather than perfect circles. When the stars get close enough at the periastral point, which is 1/3 larger than the distance between the Earth and the Sun, they may collide. This collision causes the acceleration of particles and the creation of energy radiation such as X-rays. The interaction of stellar winds also causes the formation of dust puffs, which are partial dust layers that expand and cool, observed at infrared wavelengths by the MIRI Webb instrument. This dust is a type of carbon that absorbs ultraviolet radiation from the 2 stars and is heated by the stellar wind before being expelled. In other words, the Webb images show a concentration of denser material in the form of bubbles at the edge of a dusty layer, which is more visible due to the perspective and the 7.94-year orbit period of the binary system. The combination of wind and dust production produces airborne particles that allows the age and outermost visible layer to be determined. Rings can be seen in the nebula surrounding the binary, similar to 3 rings, and about 20 rings are visible, which means that about 160 years of dust layers can be seen. The most recent Webb 140 Petriastro was discovered in 2016 by a group at the Japan Aerospace Exploration Agency's Institute of Space and Astronautical Science, led by astrophysicist Brian Lowe, so expect to learn more about it in the future. The concept of the edge of the observable universe is an intriguing notion within cosmology. the branch of science that studies the origin, evolution, and structure of the universe as a whole. Although the exact details may vary according to the latest cosmological theories and models, there are certain fundamental ideas that apply to this concept. The observable universe refers to the region of the cosmos from which light has had sufficient time to reach us since the beginning of the universe. Since the speed of light is finite, the portion of the universe that we can observe is limited by the distance that light has been able to travel since the Big Bang, the event that is believed to have marked the beginning of the universe as we know it. This means that there are regions beyond our observable sphere that we have not been able to detect because the light they emitted has not yet had time to reach us. There are several fascinating insights related to the observable reaches of the universe. Particle horizon. Due to the expansion of the universe, there is a limit beyond which particles and galaxies are moving away from us faster than the speed of light. This creates a horizon beyond which we cannot receive any information, since light or any other signal cannot reach us from some time. Age of the universe. The age of the observable universe is related to the maximum distance we can see. The farther we look in space, the further back in time we go, since light from those distant regions has had to travel for miles of millions of years to reach us. Topology and shape of the universe. The overall size and shape of the universe is subject to debate. Some theories suggest that the universe may be finite, but have no clear edges or boundaries. This implies that, in theory, we can look in one direction and see the same point in space from an opposite direction. Multiverses and other theories. Some cosmological theories, such as cosmic inflation and related ideas of multiverses, suggest the possibility that the observable universe is just one part of a larger set of universes or dimensions, which adds even more complexity to the concept of boundaries. The observable universe refers to the portion of the universe that we can observe and study using telescopes and other instruments. However, this capability is limited because light, the main source of information about the universe, can only travel at a finite speed. As a result, we can only observe objects and events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be approximately 93 billion light years, which is much larger than the estimated age of the universe, which is estimated to be 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. Overall, the universe is a vast and fascinating space, but there is much more we do not know about it. However, with the use of NASA's James Webb Telescope and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as various phenomena. Join us as we discover the massive structure that the James Webb Telescope just made contact with at the far reaches of the universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. What lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to transcend space and time, such as using a distortion engine or wormholes. These concepts have long been the subject of debate among scientists, some of whom believe that they are simply impossible, and that they contradict the idea of faster than light speed travel. The feasibility of both possibilities, faster than light travel and the use of advanced technology beyond the reach of current human intelligence, is a subject of intense debate. Even if it were theoretically possible, it would require technological advances in machinery that are currently beyond our capabilities. The theory of cosmic inflation posits that the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. This number is so vast that it is incomprehensible to the human mind, since we cannot see or measure the unobservable part of the universe. Therefore, we have no way of knowing with certainty what lies beyond its limits. However, that does not mean that we cannot develop theories based on the information we have gathered from distant galaxies, and this is where NASA plays an important role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Telescope became operational this year, NASA had already published images of the ultra-deep field obtained with the Hubble telescope. When the James Webb Telescope made its debut, it was taken out to observe the most distant galaxies ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos. Apparently, as they were millions of years after the Big Bang occurred, approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. These data revealed the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we are alone in this vast universe. However, these new determinations within the observable universe leads us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Are there extraterrestrial beings somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system, known as exoplanets, which have been discovered using techniques such as the transit method and the radial method. Some of these exoplanets may have Earth-like characteristics and harbor life. This theory has been supported by another discovery made thanks to the James Webb Telescope related to the exoplanet WASP-96b. This planet is located outside our solar system, and its light spectrum revealed something surprising: the presence of water molecules. In addition, the spectrum also shows signs of haze and clouds, which were not previously thought to exist on a habitable planet. Based on the habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. The multiverse is mainly discussed in the concept of quantum physics, which deals with the behavior of tiny particles such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative, and it is not yet supported by conclusive evidence. It is therefore difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrödinger's cat thought experiment or the nature of darkness. It is a concept that arouses fascination and reflection, but requires further research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The question is complex and raises an intriguing issue. Dark flow emerged in 2008 as a possible explanation for the observation that some galaxy clusters appear to look faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy. that pulls them in a specific direction. However, the existence of dark flow remains controversial and has not been accepted by the scientific community at large. Some studies have suggested that the dark flow may be real and could be caused by the presence of a massive structure in the universe that exerts an attraction on galaxy clusters. However, other studies have failed to confirm the existence of dark flow and have proposed that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected galaxies. While some other studies suggest its possible existence, we cannot state with certainty its presence outside the observable universe. More research and evidence is needed to better understand this intriguing phenomenon. What do you think? Let us know in the comments box. Remember to like and subscribe. Thank you so much for watching. See you soon.